Okay, guys, so today we are doing day 3 of the periodic table and trends, conflict and cans. All right, so this is going to get us into groups and periods. So, the Bohr model of an atom, pretty much shows you having a nucleus in the dead center, and from the nucleus, all right, if we just make this, actually, let's make it a little positive. I'm just going to show a positive. Now, there are neutrons and protons in here. I'm just making it small just for this second. And then we're using the Bohr model to kind of represent, all right, these energy levels, even though we know that they don't look like that now because of the quantum mechanical model. We're using these because they can still help us, all right, figure out, it can still be like a useful diagram for representing the position of electrons in different energy levels. So we have these little orbits, as we will call them. Okay, so we have the nucleus, first orbit, second orbit, or energy level. So each new ring is a new energy level. Yes.
Thank you.
All right, so there's a rule in this, all right, the very first ring. Okay, very first energy level can only hold two electrons. Each ring after each energy level after can hold 8 electrons. Now, what we're doing is we're going to complete the Bohr diagrams for the following atoms. Afterwards, our main goal is going to be to determine the number of valence electrons. What are valence electrons? Valence electrons are the electrons in the outermost energy level. All right, so we're not going to do those until I ask you guys to do so. But our first example here of lithium. All right, the atomic mass, or mass number on top, atomic number on bottom. Okay, 7 minus 3 would give me 4. So a mass number minus the atomic number gives you the number of neutrons. That's why we have 4 neutrons here. Protons is the atomic number. So that bottom number is going to tell us what element it is on the periodic table. And it's going to tell us, all right, how many protons. So protons and atomic number tell us exactly what element we are dealing with. So we're looking at 3. Number 3 on the periodic table is lithium. Okay, excellent. So we're going to ignore the valence electron piece right this second. Now let's take a look at beryllium. How many protons does beryllium have? 4, right? The atomic number is 4. We're considering these all to be neutral atoms. So again, if you don't remember, neutral atoms, same number of protons as electrons, or same number of electrons as protons. They're same. So their charges balance out. So that's why we're going to have 4 electrons here. Now, how am I to determine the neutrons? Well, I'm going to do mass number minus atomic number. What's 9 minus 4? It is 5. Okay, so now we got to draw in the electrons. So now we got to draw in the electrons. How many electrons go in the very first ring? 2. Okay, just put them on opposite sides of it. And then, how many electrons do we have left that we didn't use yet? 2, right? Because we have a total of 4, so we have 1, 2. So not in that first ring. Now it's in the second ring. We're going to put in 3 and 4. Cool. So, the remaining 2 energy electrons go in the second energy level. So I would like you guys to figure out the remaining protons, electrons, and neutrons for the rest of this row. So for 3A, 4A, 5A, 6A, 7A, and 8A. So right now, I want you guys to complete that. Don't worry about the number of valence electron, but I want you to complete.
Are we drawing them?
Yes, you're going to draw them in. I want you to draw them in as well. Yes. No, so first one can only have 2, and then each of the other rings following can have 8. And then if you have more than that, then you'd have to go on to another from there. Okay, guys, so everyone should be doing this right now.
So you would move on to the last one only if the other one has 8 already? Or you could
Correct. So if I would only move on to, right, if this is the first energy level, second energy level, I would only move on to the third energy level once the second energy level has a total of 8 electrons. That's a very good question. All right, so let's go through that real quick, guys. So we should have these guys filled in. 1, 2. We have 3, 4, and 5. The next one we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Next one, 1, 2, 3, 4, 5, 6, 7, and 8. Whew. The next one. All right, how many electrons though is that in the second energy level here?
8.
Well, 1, 2, 3, 4, 5, 6. So we've used a total of 8 electrons. So the next one, 1, 2. Now remember that second ring can only have a total of 8. So we got 1, 2, 3, 4, 5, 6, and 7. So we have these 2, and now we have the 7 that adds, all right, gives us our total of 9. And the last one, 1, 2, and then 1, 2, 3, 4, 5, 6, 7, and 8. So we have a total of 10 electrons here. 2 in the first energy ring, 8 in the remainder. Okay, good. So, let's see. How many energy levels do each of these things have?
3.
Well, how many energy levels are being currently used by each of these? 2. 2. Okay, good. So, rows on the periodic table, they are called periods. All right, they are called periods. So, what period do each of these guys belong to? So, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So, what period do they belong in? Period 1, 2, 3, 4, 5, 6, 7. What period do they go to? Period 2. All right. In period 2, well, how many energy levels were kind of being used up? Right, 1 and 2, 1 and 2. So they all wind up having here, all right, 2 energy levels in use. Okay, so periods go across. Periods go across. How can I memorize that? Like, how is a sentence written? Vertically or horizontally? Horizontally. And what do sentences end with? Right, so period. Hold out your fist like that, right? You're writing something horizontally and hold your fist out, okay? Ends in a period. Cool. All right, that may be a way, a little cue for that. Now, valence electrons. There are the number of electrons in the outermost energy level of an atom. So if we're looking at the Bohr model for lithium, how many electrons does it have in its outermost energy level? 1. And that is why it has a valence electron number, right? It has 1 valence electron. So how many valence electrons does beryllium have? 2, because there's 2 in the outermost energy level.
So you're just going to subtract 2 from the electrons?
Not always. It would work. That would work just for this specific case, but not always. So you just, if you can, look. If there's a drawing like this, just look at how many are in the outermost level. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 6. How many do you think would be in the next one then? 7. And 8. Okay. Very good. Very good. So what patterns did we see here? What is the pattern then? Okay, so it increases as we go which way? To the right. So as we go to the right across the periodic table, we are gaining an extra valence electron. Okay, awesome. Now, let's see, what else do we have? Now, what we're going to then take a look at are columns. What we're going to look at are columns. Now, columns on the periodic table, they are called groups. What do you do with your group of friends usually? Hang out. So if you were to demonstrate just really quickly, if you were to hang on a bar, how would you do it? Show me. What direction does that go? Vertically. All right. So groups, you hang out with your groups. You raise your arms up, right? You're holding on to something. You're hanging out. So you are vertical. So vertical columns are groups. Sentences are written, all right, horizontally, and end with a period. So the horizontal rows are periods. The vertical or groups, they are the vertical or columns, they are called groups. So those are the guys that we are dealing with here. Okay, now let's see. I want you guys to match the elements in the chart to their columns on the periodic table. If you can, all right? If you have your periodic tables, if you take your periodic tables out, if you don't already have them, match them together. Okay, in what rows are there? I'm sorry, we're matching C groups. So what group is sodium in? Very good. Sodium is in group 1. What group is magnesium, Mg, in? Group 2. All right, so we went from 1 to 2. What group is aluminum in? Go straight up. 13. What about silicon? What about phosphorus? 15. Sulfur, chlorine, and argon. 18. Okay. Interesting. Now, let's see if we can zoom out just a little bit to see this. So lithium, sodium, they're in the same what? They're in the same group, not in the same period. What about beryllium and magnesium? Are they in the same group? They're in the same group. What about boron and aluminum? Same group. What about carbon and silicon? Same group. Again, same thing with nitrogen and phosphorus, oxygen and sulfur, fluorine and chlorine, and neon and argon. So they're all basically sitting directly underneath each other. Okay, so keep that in mind because that's going to come into play very soon. So what I'm going to ask you guys to do, we'll do one more example, and then I'm going to have you guys finish, all right, the period. Sodium. How many protons should I have?
11.
Okay. Neutral atom means how many electrons? That. And mass number minus atomic number. 23 minus 11? 12. So now I have to fill, or it's already kind of filled in for us. So let me see if I can zoom in. We have 1, 2 on the very first ring. So that got rid of 2 out of the total of 11. Now the next one. All right, we can have a total of how many? 8. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have a total of 10 used. But we have 11 total, so we would have to go to the third energy level. So once we go to the third energy level, there's only 1 electron there. Now let me look at this. What period is sodium in? Is it in period 1, 2, 3, 4, 5, 6, or 7? Period 3, right? 1, 2, 3. And notice that its outermost valence electron is in which energy level? Not the first one, not the second one, but the third one. And now that is why it has 1 valence electron. So what I want you guys to go through right now is I want you guys to continue and complete protons, electrons, neutrons, and then valence electron numbers. All right, so I want to see you guys. I'll give you guys like 3 minutes, 4 minutes to complete protons, electrons, neutrons, and then draw the dots in, and then you can do your valence electrons. All right, so please work on that right this second. All right, so this is what it should look like. Mg should have been 12 protons, 12 electrons, 12 neutrons. And when we draw it in, now we should only have 2 valence electrons. Aluminum, 13, 13, and 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Silicon should be 14, 14, and then 16, because 30 minus 14 is giving us 16 neutrons. Okay, 2 in the first. 1, 2, 3, 4, 5, 6, 7, 8. That would be a total of 10 now. And this would be 11, 12, 13, 14. So So there's 4 in the outermost energy level for silicon. All right, we kind of continue to go through. Phosphorus 15, 15, 17. You should have a total of 1, 2, 3, 4, 5 in the outside. The next one, 16, 16, 18. Okay, we go, should be 2, 8, and then 1, 2, 3, 4, 5, 6. 17, 17, 18. The outside should have 7 electrons, and the argon 18, 18, and 22. The 22 comes from 40 minus 18, mass number minus atomic number. Now, valence electrons, we can just go along and count. There's 1 here. How many valence electrons do we have for magnesium? How many electrons are in the outermost energy level? 2. Correct. How many for aluminum? Silicon? 4. Is there? You guys see a pattern emerging again? So what do you think the rest of them should be? 5, 6, 7, and 8. Okay, very good. So that is what we should have here. Where the heck is the mouse? There it is. Okay. So as we have that, as we have all of that now, let's see. We're good with that now. You guys did the rest. So these elements were in which period again? Period, guys. How do we write a sentence? Vertically or horizontally? And what does it end with? A period. So what period? They're in period 3. All of these guys are in period 3, which is why their outermost electrons are on the 3rd energy level. Okay, and then let's see, what else? Let's see, what about groups? What about groups? You have lithium, sodium. You have lithium and sodium. Are lithium and sodium in the same group? Yeah, they're in the same group. How many valence electrons does lithium have again? 1. And then how many does sodium have? 1. Interesting. Beryllium has 2 valence electrons, and so does magnesium. Scoot across to group 13. Boron has 3 valence electrons. Aluminum has how many? 3 valence electrons. Carbon has 4. Silicon has 4. Nitrogen has 5. Phosphorus has 5. Oxygen is 6. Sulfur is 6. Fluorine has 7. Chlorine has 7. Neon has 8. And argon has 8. So, what does that mean? What pattern is that telling us? If you have elements that are in the same group, they will have the same number of valence electrons. Okay, very, very important to know that. All right, so even though they're in different energy levels, like these guys, all right, he had an electron in only the 2nd energy level, but it was the 1 in the outermost. This one has only 1, even though it's in the 3rd energy level, it is only 1 in the outermost for that element. So elements in the same group have the same number of valence electrons. Why is that important? Well, guys, and I cannot stress this enough. Valence electrons are very important because atoms will form bonds with other atoms based off of their valence electrons. All right, so therefore, valence electrons are involved in a lot of the chemical properties of elements, whether or not they react, can form new things, all right, create new stuff. So that is very, very important to note. That is very, very important to note. So from here, you guys flip over. From here, when you guys flip over, you guys are going to take a look, all right, and go through these now and answer these to the best of your ability. How many valence electrons should each of them have? How many energy levels would each have? How do you determine which energy level or how many energy levels they have? By what period they are in. So, how many energy levels did lithium and beryllium have? 2. Why? Because guess what? They're in group 2. I'm sorry, in period 2. How many valence electrons did beryllium and magnesium have? How many valence electrons do these guys have? 2, because they're in, all right, group 2. Now, wait a minute. Why is this a thing? Because now it goes to 13. We'll get into it in the next day or so, but these guys down here, they are transition metals. Valence electrons are only held in the very outermost energy levels. So there's a specific order that we'll get into, but basically these guys would be 3, 4, 5, 6, 7, and then everybody over here would be 8, and there's only one exception. There's one exception, and that would be helium. Helium only has 2. All right, why? Well, it only has 2 electrons. So when you go to fill the actual diagram, if we just kind of block that up, that would be essentially helium. If it has its nucleus there, and it's got 1, 2 electrons, it has a complete energy level, but that's it. It has no more. It doesn't have a full 8. But everybody else in that group, in group 18, all right, or on this paper it says group 8A, they will all have the same amount in their very outermost one. Okay. So now you guys are going to go through. You're going to answer those questions 1 through 8. Then you guys can work on these together. Little element joke activity. All right. Use the periodic table to determine the punchline of each elemental joke. Yeah. And then, all right, getting this, Dmitry Mendeleev, may be best known to be the father of the periodic table. But he was not the first or last to try this, putting the elements into some form of order. There was a guy before him, Lavoisier, put together a basic list of 29 known elements at the time. He had other organizational plans, but they were lost when he was beheaded a few years later. Yes. 1829, there were 56 known elements. Dobryner noted that if he had 3 elements with similar properties ordered by atomic weight, he could predict properties of one of the elements using the other 2. Other chemists found this idea of periodic trends interesting, but it didn't have much data to fully illustrate his theory. 1864, 64 known elements. When Englishman John Newlands arranged them by atomic weight, he noticed that every 7th element shared similar properties. He called his observation the law of octaves. Perhaps because octave means 8, not 7, the Chemical Society of London openly mocked his ideas and refused to publish them. Russian Dmitry Mendeleev and German Julius Meyer, both trained in the same laboratory in 1868. Both created tables that ordered elements by the atomic weight, and then they placed them in columns based on their similar chemical properties. Both claimed to have no knowledge of the other's work. Mendeleev's table was published in 1869, Meyer's in 1870. Well, guess what? This guy had a better publicist. We know him to be basically the father of the periodic table, not the other guy. So, continuing on with that, by 1890, all of the noble gases had been discovered. While Mendeleev's table brilliantly predicted the future discovery of several elements, he had not anticipated this particular non-reactive group. A new table was drawn up. Now similar properties were found at every eighth element. John Newlands was given a nice plaque by the Chemical Society of London. That was, yep. That was the guy who, let's see, where was he? This was the guy that tried to come up with like the law of octaves, but didn't work. But once they've kind of figured out that, yeah, every eighth element that they were using had very similar properties, they went with that. And then 6 years after Mendeleev's death in 1913, a amateur physicist suggested that perhaps the best way to organize the elements was by their nuclear charge, but no one knew how to measure nuclear charge. So English physicist Henry Moseley found a way to measure this atomic number right before he was killed in World War I. Today's periodic table contains about 118 elements arranged by atomic number. Not enough is known about some of the most recently discovered elements to know if their positions on the table are predictive of their properties. Only a certain, but it is certainly a matter of time before we do. So you'll be able to then answer those questions from that. All right. So you guys have to finish this, complete questions 1 through 8, and then complete the elemental joke activity. Yes.